It.
Yeah, thanks, Nishant. Morning, everyone. So in today's session, I will be giving a demo of the volume policy that would be coming in 0.6.0 release. I would also do a code walkthrough of how exactly it has been done, why it has been done in that way. And of course, we can have the suggestions, the questions, and all those things. I'll try to answer them as much as possible in this session. Okay, let me share the screen. Okay. Okay. So I hope my screen is visible to all of you.
Yes, Amit.
Okay, fine. So we have a list of issues related to storage policy. If you see 1010, the issue number, I remember it because it's very easy to remember. So this is one of the issues where it talks a little bit about the policy. However, the details can be found out in this particular document. The document tries to talk about the requirements behind the volume policy. And then there is a presentation which we had done last week in this particular meeting about how it's going to look like, what a volume policy is going to look like. And if you scroll down further, I mean, there are a lot of PRs and issues that have been linked to this particular issue. So you will see a lot of stuff related to this particular issue, but keep scrolling down and in the end, the last comment, I guess is the last comment, we'll find some of the steps that one is to do before using the volume policy. It's mostly about the YAMLs. We have to set up a lot of YAMLs before we can even think of using a volume policy. We'll go through them. Okay, and at the last, you can see that after the YAMLs and everything is getting created, these are some of the APIs that needs to be called. Obviously, in our case, it will be the OpenEBS provisioner, which is a dynamic Kubernetes storage provisioner, which will be calling all these APIs. And those things, again, will be exposed as a YAML to the users. When I say YAML, users will still be required to use the PVC, PV storage class YAMLs. User will be setting them up, and when a PVC is invoked, a persistent volume will be created. So from the user's point of view, everything will be the usual Kubernetes specifications, and it will be internally be translated, transformed into OpenEBS specifications. All right. Okay. So what I feel is, okay, is there anyone who has not gone through this particular presentation? I would say like this holds the key to understand the thing. I would try to be very quick here before I get into the code. So this is, I'll just open the presentation. Okay. This is what a volume policy will look like. It will have a name, and there will be n number of policies mentioned, and there will be some templates. So the templates are some things that will be executed in sequence in a particular order, the order that is mentioned here. If you go the next, these are some of the policies, there can be a lot of policies and it can be configured. Finally, like we discussed last time, these will be forming as a kind of a catalog based on the node, based on the OS, or based on a cloud platform, let's say Google Cloud or Azure or whatever. Those will be forming a kind of a catalog for the users to use them. Okay. So again, a policy corresponds to task. If we go back, so we see some of the policies that can be mentioned here. These will be corresponding to tasks. Tasks are nothing but templates. And so when I talk of templates, one can assume it, or one can think about Helm-like templates. It's very similar to a Helm templates. And right. So there will be some volume policies which will correspond to a task, and the task will be executed by Maya, right? The control plane of OpenEBS. Again, so coming to the task, what is a task? We will look into these things currently. What is a task? A task is nothing but a Kubernetes specification, which is, and we are specifically interested in using config maps. So this is kind of a placeholder where we can push in some key value properties. And there are some of those properties that we have defined, for example, meta task, and then the actual task. So meta task will be having some informations like, is it a Kubernetes service? Is it a Kubernetes deployment, or is it something related to some Kubernetes objects? Maybe it can also be a Kubernetes custom resource. And so that definition will be set here in this kind. All right. Then there is something called actions. So when the meta definition of a task has something called action, the action can be, let's say, put, get, and so on. Put implies it will be deployed into the Kubernetes environment. Get implies that particular kind will be extracted from Kubernetes deployment, and so on. Excuse me. Again, if you see the run namespace, so run namespace, typically, again, it boils down to the Kubernetes namespace where this action will be executed, where the task will be executed. So this is all about the task meta. Then we have the task specification. Task specification will actually embed an entire Kubernetes specs. We'll come to this once again. Okay, this will be this is a kind of an example of a task, and if you can see the meta information being put in, then there are information about the entire task being put in. And if you see, there are some curly braces here. These are nothing but the placeholders. This looks very similar to a Helm template, and these are set at runtime. Okay, and if one must be wondering, like, how does it get set? So this is where the policies will come into picture. The values that are set in the policies will be replaced here. Some of those things may not be available in policies. Let's say, for example, run space, run namespace, owner, and all. Those are the runtime stuff. For example, the policy will never specify where it is to be run. Rather, it is the PVC which specifies, right? It's a PVC which triggers which is a namespace where this volume needs to be created. So it will come from the PVC and it will come and get set here into the task. The task get executed, and after the execution, we'll see some volumes getting created. Okay, I'm going faster, I know that. Okay, so this is all about the last week presentations. Okay, so this is primarily taking care of provisioning an OpenEBS volume, and these policies will be provided as kind of a catalogs and all those things. Users can create their own policies, and the tasks are similar to a Helm template. All right, so I'll start the presentation here, and we will go to the code. I'll just get into the code walkthrough. Okay. As you can see, this is the clone of our Maya repository, the OpenEBS Maya. And if we look at the folder structure, right? So it has got, quite a number of folders. And in Go, it's known as packages, the namespaces. You can see that a lot of them. all of them do not belong to the source code. For example, there is something called build scripts, right? Those do not belong to the source code in general, but related to the build and all. And we have in this particular version of volume policy, we need to be aware of the build scripts. I'll come back to why. Okay, and then we have something called org provider. This is actually older version. This is for these for the Maya 5.0 and before that, where org provider was a means to provide orchestration via Kubernetes, or let's say earlier we were using Nomad and all those things. So it's the kind of abstraction to container orchestrators. We have a PKG folder wherein we have got all the business logic starting from 0.6.0, and I'll come back again to why PKG. Further, we have, let's say, scripts, templates, and all those things. These are related to some, I guess, Docker templates and all those things, right? The Docker files. Finally, if we go down, we have something called volume. So volume, along with org providers, where the packaging, where the namespaces that we have been using, even we use them now, and we have been extensively using them till 0.5.0. Maya release 0.5.0. However, we are slowly moving into the PKG to have our core business logic. All right. Now, having said that, there is yet another folder which is a very important, very important for Maya. That is a folder CMD. So this is the one which holds the binary representations. The OpenEBS control plane can have, or let's say the OpenEBS can have a lot of components. One being, let's say, Maya CLI. The other is Maya API service. There is yet another one, which is a Maya nodebot, which takes care of the disks, right? So, so all those components which are coming out of OpenEBS, they are all inside this particular folder. All right. However, the core logic, right? The core logic will be found around in the PKG folder from now onwards. In earlier releases, it was present in org provider as well as the volume folder. All right. So what I will do is I will start with how the code flow is executed in Maya for provisioning a volume, right? And for that, we will go to the package CMD. Okay, so if I do a CMD folder, we can see these are the list of components that Maya currently provides, the OpenEBS provides, right? Maya agent, I think this is the old name for the node bot, right? Then we have got Maya API service, that is a Maya API server, which exposes REST APIs, the REST endpoints, right? We have got Maya CTL, this is the CLI, and we have got Maya volume exporter. This is nothing but a Prometheus integration for the OpenEBS volumes. Okay, so we will straight go to the Maya API service because that's where we are interested in this particular session. That is provisioning a volume, which will get invoked when the provisioner calls the create command, the create API. All right. So if you see the CMD, then we have got Maya API. Right here. So like you see, this is a typical folder structure that we have been following. And that this is again a kind of a Go standard structure. This will result in creation of a binary for Maya API server. All right. So what I'll do is we'll go inside. All right. So so main is nothing but it will be helpful in creating a binary with a particular name. It will be taking out the flags or the arguments from command line if it is required. For example, the log level and so on. We are not interested in that. We will get into the app folder, which has the business logic. Right. Okay. So here we are. We'll go straight into the server, which hosts the REST endpoints. We shall not talk about the other ones here. If we go into the server side, right. So what we see here is in this particular folder structure, right? We see a set of Go files. These are only meant for exposing the REST endpoints as a HTTP service, right? So my API server is nothing but a HTTP service exposing some of the endpoints, right? As the name suggests, we have something called snapshot, volume, and there is something called metadata, out of which let's not bother too much about the metadata. We haven't really have some proper logic. We don't have a good business logic in the metadata. It's just kind of a validation that we have there. We will talk about the volume endpoint, and to those who have been looking at the HTTP, this is nothing but a typical, some Go program, some Go logic that exposes HTTP, right, using the net HTTP package, the standard library of Go. Like I said, let's not bother too much about the HTTP. It's just something that exposes HTTP APIs. However, we'll get into that logic, get into that particular Go file to see the mapping of the REST endpoints with respect to the handlers. We'll come back to that. We will see that once again. Okay, so what I'll do is I'll open up the http.go file, and there is one particular method where it registers the handlers. And if you see, these are the various endpoints, right? And the right hand side, or rather the next argument of this particular function, handle function, is the handler. So whenever a request is made to the HTTP service, that is a API service, which has the URI with something like /latest/meta-data, it will come here and it will be, it will execute, it will be given to this particular method. All right, so, okay. So again, here is if you see this particular method, these are nothing but, these are some of the wrapper logics. These are some of the decorators we have written to expose the matrix of this API service, right? So it's something called counters and the durations. These are all finally analyzed in the Prometheus, right, after the exposure. So finally, this is the method. This is the handler method. So when a request comes to latest metadata, meta-specific request is the one. It's just a method, right? It's a method which handles this particular request. So in our case, because we're talking about volume provisioning, it has to come around this, the latest volumes, right? And you'll go to volume specific request. Okay. So having said that, the release of my API service till 0.5.0 has been using this particular URI, right? From 0.6 onwards, it will use the older one that will be there for backward compatibility, as well as for the volume. However, for the volume policy, for the new volume policy, the provisioner has to request this particular URI, which has v1 alpha 1. We are giving it a name, v1 alpha 1 / volumes. So the request that has v1 alpha 1 in as his version in the URI itself, it will come here and it will be intercepted by this particular method, which will again have a big name like volume v1 alpha 1 specific request. Okay, so this is all about HTTP, how the requests are intercepted with respect to the URI patterns, right? Okay, so now we go back to our server package, right? So if you see, there are like a couple of things here. There is something called volume endpoint, right? And there is something called volume endpoint v1 alpha 1. So if you have guessed it correctly, this is a particular file which will be handling the new requests. That is a request that are catering to the v1 alpha 1 endpoints. So we will get into this particular file, right? All right. So this particular file has got some structures which composes the request and the response. And the request and the response are nothing but these have been defined here in this particular package. When I say here, it's a package server where it has been defined. And then, if you remember, this was the handler method that we had seen in HTTP. See, it's a volume v1 alpha 1 specific request. The same thing comes out here, right? Okay, so this is all. I mean, the logic is very is very simple. It does some switch cases, and based on that, it has got the logic. If you see, if I really scroll down, right? Yeah, if I scroll down, if it is a get request, it will come to something called it will try to further find out if the request is an info type request or a delete kind of a request. Yeah, so the delete should not be a part of the get, but we have it. We will be modifying that to a delete request that complies the HTTP verbs, the HTTP standards. However, this is what it is. So, but the thing of our interest here is the volume create. That is where the provisioning comes into picture. So the request has to be a put or a post, and if it is that, then it will immediately get into the create part. So in the create, this is where the entire thing, the logic of create. So the first thing that it does is, this is one of the important things. It decodes the request and it, unmarshals it to the volume. That's a go structure. When I say it unmarshals the request into a volume, here it unmarshals the YAML. So we have been following the Kubernetes principles here. So the Maya API service accepts YAMLs, and it also delivers or produces some different YAMLs, right? It accepts its own YAML that it understands, whereas it results in some Kubernetes YAMLs, right? And in between is the Maya API service, which is doing all these logic. So here it unmarshals the YAML and does some verifications, right? All right, so it does some verifications, and finally it calls, it instantiates a particular object that is known as a volume operation. We'll go to here, and finally it calls the create, right? And so that is it. Once it calls the create, it actually returns that particular volume, which again will be, this particular volume is one which is, which will be, used by the provisioner to create a PV, a Kubernetes a persistent volume, right, specification. So here we don't find any relatively important stuff. It's all about unmarshalling and calling up, invoking the logic and getting the result and just sending it away, right? So other things, so like the v1 alpha 1, we have not implemented the read, delete, and the list APIs. Having said that, we know that there is something called latest, right? So the latest get, list, as well as delete works fine with respect to the volumes that are created using the V1 Alpha 1 stuff. All right. So this is the end of the service part. That is a service package, right? So in other words, this is also end of the CMD package, right? So this was a package which received the HTTP request and calls some of those internal, you know, packages to create a volume. We'll go into these things now, the volume operations, right? So those are the things. So what we'll do is we'll get back now. So now we are in the root path, right? Okay. So like I said, we'll get into the package, the PKG folder, right? So this is the one which has got the current business logic. And if you see the, I'll come back to some of these things eventually. However, because I'm continuing with the flow will come to this particular package. It's a volume package which will come. So this is the volume. So this is nothing but it comes from this import statement, which is something called Maya PKG volume, right? So so this is where we are interested now. We'll get into the volume. All right. So if you see, it has something called volume.go file and a policy file. And like I said, we will go to the volume file. All right. So yeah. All right. So this is the operation that was invoked from the HTTP handler that we saw now. That is new volume operation, and this in turn accepts a volume kind of a object, right? This has all the properties that are requested right from the PVC. For example, the capacity, it will be there, which namespace it needs to be provisioned, the volume needs to be provisioned, it should be here, right? These are, I mean, typically the two mandatory things that comes from the Kubernetes scheme of things, especially the PVC, right? I have not talked about policy yet. We will talk about it when I see the policy related stuff. We will be talking about it, right? So these are some of the basic validations, like namespace will be there. It cannot be nil, right? If it is nil, there is nothing to be done. Again, so these are the ways. I have written those error statements. We can actually discuss about that maybe in the review comments or maybe at the end of the session if we should have something, some other ways of specifying the error messages or any other feedback suggestions. We can actually take it up. Currently, I'm just trying to doing this kind of things. All right. Okay. So after a few basic validations, it has to get the Kubernetes client, right? So this is the client. Again, this is our wrapper. This is the Maya's wrapper around Kubernetes API, right? It is the one which will help us to create, to call all the crude APIs, create, delete, list APIs of Kubernetes objects. For example, PVC, PV, storage class, deployment, stateful set, anything. I mean, when I say anything, it has to be coded out in these wrappers, right? Okay. So here it actually instantiates a volume operation. If you can see, if you can see we'll go to the create method. I think that's the only method that is done. The other things has already been done. Right. So so here so the create method, what it does, it looks out for the capacity. That's the first thing that it has to check out, and the capacity is one which will not be present in the PVC. Okay, so here there is a difference from the earlier, the earlier way of doing things. Let's say, for example, in 0.5.0, the Maya API service used to look for capacity at multiple places. First, it will look at the PVC. If it's present, it's fine. It will take it. If it's not present, it will try to look out for some, environment variables or some defaults from some constants, right? However, that actually what I saw is that triggered a lot of queries from our CI team, and definitely I could see that it would be a concern from the users as well. If we have multiple ways of specifying the capacity, and Maya overrides those capacity in one way or the other by following a priority order, it looks good, logic wise, but I felt that it was creating a lot of unnecessary confusion among the users. So from this particular version, that is a V1 Alpha 1, it just looks out for the capacity from the PVC. Okay, if the capacity is not mentioned in the PVC, it will just error out. Okay. Of course, we will not find those PVC elements all here, because the PVC is provided to the provisioner, and provisioner creates its own structure and gives it to the this particular logic, that is a Maya API service. So you don't find anything called PVC.capacity or something like that. But this is all about the PVC. This has come from the PVC to the provisioner to the Maya API service. And then we have some validations. We also do the validations of the client, the Kubernetes client that we talked about. It will be instantiated during the instantiation of volume operation, that is this object. This all things should be there. Otherwise, it cannot just go and create a volume, right? All right. Again, other important thing is Kubernetes storage class. We are mandating the use of a storage class, being a dynamic provisioner. Kubernetes expects the dynamic provisioners to be registered to a storage class, and hence this particular validation. And we have tied the volume policy to storage class. So in our case, it is like very critical for us to have the storage class. Without that, we really do not know what to do, right? The API service do not know how to provision a volume. With just a capacity, it just cannot go ahead. Right? So it requires a storage class, right? So storage class in turn will give us the volume policy, right? Okay, I'll just move to a YAML, which will actually clear this thing. All right, I'll go to 1010, same thing. Right, so we have the storage class here, and if you see the storage class that I was talking about in the code, that will have something called OpenEBS volume policy with the name of the policy. This is what we are much interested with, and without a storage class, we cannot have a storage. We cannot get to know about a volume policy, right? So this is the thing that this particular thing, the last line of this snippet, this YAML, is being extracted now in this particular line of code. Okay, so after extracting the volume policy, we go ahead and so we go ahead and do something like this. We extract the policies we extract. Okay, till now we have not extracted the. Okay, all right. So like I said, we get the policy. Once we get the policy, we create a structure which has the the mandatory volume characteristics. For example, the name of the volume, the capacity of the volume, and the namespace of the volume where it is going to be run. These are some things which will be provided from the PVC PV, from the PVC and from the OpenEBS provision side, right? And we don't mark it with the policy, right? The policy will not have all these things. We create a structure. If you see, this is a kind of an entire structure we create and we provide it to the policy engine. So this is where the policy engine comes into picture, right? We get an instantiation of the engine here, right? And if you see, the first argument to the engine is a volume policy. So what we provide to the engine is the volume policy, right? And the other set of data that we receive from the PVC, and it is the name, capacity, and the namespace. All right. With this, the next part will be the execution of the engine and returning whatever was executed. Some of the data needs to be returned, right, to the provisioner so that it can go ahead and create a persistent volume, right, which will be consumed by the applications. Right. So currently, what I saw is the annotations are the only things that we can actually set to the volume, and and that is in turn returned to the provisioner. Right. It will return to the handler, and that in turn will be returned to the provisioner. All right. So this is all about the invoking of engine, the policy engine. Right. We'll go back to our code. So the policy engine is all framed in this particular file, policy.go. We'll do that quickly, right? So here are a set of stuff. Okay, so rather than going through this particular piece of code, I would what I'll do is I will let us go through one example, which will benefit us, which prove us how this policy has been done. Gedit. Okay. All right. If you see, there is something called TXT template examples. If you see the PKG, if you see the template folder, there are two things. There is a template and there is something called examples. We will look into the examples part because that can explain us a lot about how the policy engine has been defined. Okay, so right, all right. So we'll talk a little bit about the templates, right? Because that is the foundation of our own volume policy. To actually implement the volume policy, what we have done here is make extensive use of some of the standard Golang packages, right? That is the TXT template. All right, this is a templating package provided by Go, and we also make use of the templates can be anything. It can be of any format. However, we are more interested in the YAML format, right? So for the YAML, we have made extensive use of this particular package, right? And to those who are wondering if it is the Kubernetes way, so Kubernetes itself uses this stuff, right? This is a package which Kubernetes uses, and this is a standard Golang packages. There is no doubt about it. We have to just use it. And there is yet another thing called Sprig, which we haven't used extensively, but this is the one which will actually give us a lot of flexibility in the templates, in the templating. Without getting into the coding aspects, we can expect a lot of flexibility due to this particular package. I'll talk about it a little bit more. And if any one of us has seen a Helm template, the Helm template is nothing but it uses these things, these three. All right. So there is nothing, particular about the Helm template. Uh, it has exposed some of the functions of its own, but it uses these all libraries to make them possible. Okay. Now we'll get to the the coding aspects of this template, right? By looking at these examples. This is again a test file underscore test.go file. If you see, um, okay, if you see this particular statement, this is a kind of a YAML, right? A YAML template which has some of these curly braces. Again, this looks like a Helm, but it's nothing related to Helm. It's actually boils down to the Golang standard templating package. Okay, this is one of the ways to write a template as per the Golang standard package, this template package. If you see, there's a config map. I define a YAML, right? Let's not bother too much about Kubernetes specifications now. Imagine this is a YAML, right? It's all in a YAML format, and there are some placeholders, right? There is something called message, block, NFS, and there is also something called this, if equals this, if equals CStore, then do this, otherwise don't, right? So these are some of the very powerful templating techniques that we can use, right, in our templates to achieve a lot of things, to achieve a lot of permutations on those combinations, right? All right. What we will, okay, so this is the template, and this is the expected version of the template, right? If you see, this is the output. Let's say when I talk about this template, right, this is the one which we will be configuring as a task. Okay, it will have set up these placeholders, and we expect the execution of the provisioner, right? When the provisioner executes, it will deploy, or it will generate this as the output, right? How? So the how part is by setting up these templates, right? The placeholders, and those placeholders are here again. I defined a sample. So these all are samples, just for a better explanation. If you see, this is a kind of a map, right? A nested map, a complex structure, which has a specific property in a specific hierarchy. If you say under my, there is something called name as a value, OpenEBS. Then there is a similar, on the same levels of my, there is something called storage. And within that, there is a nested property called favorite, right? Inside the favorite, there is again a nested property called block. And on the same level, we have NFS, right? We have a value for NFS called CStore again, and the block is CStore, right? So now to make use of this particular structure, right, it has to be set in this kind of hierarchy. Let's say my.name, storage.favorite.block, storage.favorite.nfs, and then we can have, like, those templating functions as well to meet our requirements, right? So this is the case where now one can think of our volume monitor sidecar. If the volume monitor sidecar, let's say if our policy has it enabled, it is turned on, then only we want a sidecar. Otherwise, we just don't want it, right? So those all things can be done via this templating very easily, right? Okay, so when I talked about all these things, the only requirement is the text/template and the YAML, right? The sprig is another requirement. I will come to the sprig. I'll show you one thing where the sprigs are required. So like I said, most of the templating functions are provided by the standard templating library. However, there are a lot of utility functions. For example, default, right? If at all, so it's very simple. It's a kind of a DSL where a user, or let's say the operator, can understand it very easily. It says that the block will have a value. What will be the value? It should be the storage.favorite.no block. Okay, so for an example, just assume that there is a property called no block. Okay, that particular value should be set against this block, right? As a problem, right? If at all there is no value, then just set the C store, right? So these are so these particular things. Let's say default, and there are some, I guess, some 20 or 30 or even more functions which are not available in the standard text template. For that, we can make use of this particular package called Sprig, right? From Masterminds. The things will be done. If you see the values in this particular thing where we are actually populating the values, right? I have commented out the no block part. It's not at all present, right? However, and because it is not present, it will take up the default, right? So this is how the entire templating works, right? If anybody has any questions till now, they can ask me the questions.
A quick one. So inside the template, can you just go back to that example template? So here you have this dot by dot name, right? And you also have another thing called dot storage dot favorite, right?
Right.
How do you associate these variables or these structures with this particular template?
Okay. All right. Yeah. So that's a great question. I forgot about the association part. All right. Let me see here. Okay. For that, okay. So this particular line, the line number 186, right? So when a template gets executed, so this particular library is the standard library. When it gets executed, we provide the raw data that is nothing but okay. We don't provide the raw data. Rather, we get the entire data into this buffer. Okay, let me actually start from the beginning. Okay, so this is how we instantiate, right? We instantiate a template object. Okay, let's not bother about this example and all these things. This is nothing but instantiation. Without even giving all these things, we can get a template. So we get a template object. Now comes the important thing. We tell the template to parse the YAML, right? So what is the YAML? YAML TPL. This is nothing but, let's say, the one which we're looking about, if equals YAML template, which is nothing but, let's say, where is it? Yeah, this particular thing, right? The template, the YAML template with the placeholders. This is the one we give it. We give to the that templating library in order to be parsed. So now at this point of time, at line number 176, we have got the template object, which has the entire information of the template. Okay. Going further, what we do is we say the template to be executed. So when I say execute a template, it will set the values against the placeholder template. How? By providing the values here. So what is this mock.values? This is nothing but okay. So mock is here. This is right. This iterates through the tests. What is test? This is a test. This is an object. Okay, so mock is nothing but an entire structure, and it's when it says mock.values, it implies these, right? All values. So now what is all values? So all values is these things, right? So this is how we associate the nested values, right, in a particular hierarchy to the template, considering that the template will obey the nesting order. So the dots should be in a proper hierarchy. If not, it will error out. It will not error out. It will just leave it as blank. Okay. So Kiran, does this answer the question?
Yes, Amit. It does.
Okay.
Thanks.
Yeah. Okay. So I actually did not want to. Yeah.
I have one question. So do we have to add a validation for these hierarchies and all things? If those are blank, so it will not break kind of stuff. So we have to add a validation for those fields.
Okay, so templating as such doesn't. It suggests not to use validations within the templates, but yeah, definitely we can add validations. Okay, that is one thing we can do. However, in this policy engine, we have not added any validations. Rather, the entire structure, right? When I say structure, the values part. Okay, if you see the values part, this entire thing gets created, right, by the policy engine. The policy engine's job is just to create the values and nothing else, right? The template, the tasks are nothing but templatized format, right? Which will be YAMLs with placeholders. The values is the one which is the core thing of the policy engine. It has to create values in a specific way, in a specific hierarchy. That is all it has to manage. So when the engine only does it, there are some validations, but we don't really need validations that it has to be in a specific order, right? But that's a good question. We should be having validations. The template doesn't suggest for validations because the template's job is to just set the values. If it is not available, just ignore it. And there can be some defaults or some if-else conditions to do some, switch case or some conditional logic. That is all the template provides.
Yeah.
Okay. So, yeah. Okay, so why I came to this particular file is this will help us understand the core of the policy engine. Other than that, the entire policy engine is all about setting those values in a proper order. If you see here, these are some of the things that a policy engine will do. It will do a policy name. The policy name is something that is given in the volume policy, right? And this is generic. One can give his or her own policy name, right? So what is constant here is this kind of properties. Let's say enabled value, that is something called data. We have not got into the data part, but it's like enabled value. These are the two basic sub properties within a policy, and the policy is a top level property. If you see in the engine, there is something called TLP. It's nothing but top level property. I mean, just definition I have given here. Okay, let's check this a volume policy. Yeah, okay. So if one looks around this particular policy, right, the policy name is called volume monitor, right, and the enable is true, the value is something like this, right? It gives an image. So what engine does is engine sets these three things, these three lines as something called policy dot volume monitor dot enabled and policy dot volume monitor dot value, right? That is what the engine's job is, and it extracts this value. That is, for enable, it extracts the true value. For value, it extracts this image and preserves that. Finally, it pushes these values to the template, right? So if you see a template here, let me just search volume monitor. What was that monitor? Just let me check. I don't know if it is there or not. Okay. So it will not be volume. It will be policy volume monitor. So if you can see that we have not used the enabled here, but we can use that to enable this entire block of YAML, right? What I have just done here is we have used the value property, that is the image property, right? So again, the value property is a very generic property. It doesn't talk about specification of an image. It can be used to specify a count as well. Okay, there is no restrictions about that, right? So if you go back, let's say these are all images. Coming to replica count, right? The value is 2 here. It's nothing to do with image. So it's a free form text. It's a string value. Anything can be pushed in. The engine just tries to preserve the value in a particular hierarchy, right? and after that it just pushes to the template. The templating does its job of setting the appropriate values. Okay, if you look at a replica count, right, which is looks a little bit different, we'll do replica count here. So this is how we access that particular hierarchy: policy.replica.policy.replica count dot value. If you do that, the value that is 2 will be set against the replicas, right? So right, so this is all about the policies. Anything with the top level property called dot policy will definitely be coming from will definitely be coming from these things, this particular section. All right. Anything that doesn't start with dot policy, it can be a dot volume. So so the policy engine has defined some specific top level properties. One is dot policy, the other one is dot volume. So dot volume is the one which comes from the PVC. Let's say run namespace, right? That is something called owner, right? So these are some of the things, right? Which actually comes from the PVC. Volume dot capacity. The capacity is the other one which comes from the PVC, right? So it is not a part of policy. It comes directly under volume, right? Similarly, there are other top level properties, for example, called task result, right? So if one understands the way we provision, right? The way the OpenEBS provisions, it provisions a service, right? A Kubernetes service, and it extracts that particular value, right? The service IP, and it assigns to the controller as well as the replica, right? So here lies the intelligence, right? Here, this is something which the template cannot do. Template's job is to set the values. So template's job is not to execute the task or not to push the task into Kubernetes. This is where the policy engine and the Kubernetes clients and all, they have to do the job, right? So they will execute it and they will try to extract the service IP, okay, and put it under a top level. The engine will put that under a top level property called task result, right? That is something called ID0, ID1. I'll come back to that, but let's talk about task result, how it goes. I think I will overshoot the time. Let's see. We'll go to the volume policy a little bit, and then I'll come back to that. Okay, so if you see, we are here in the volume policy, right? Here, if you see the tasks, there is something called run, and there is something called search namespace. So search namespace is the one where these templates will be searched, but this is definitely not the one, not the namespace where this will be run. This will be run in the namespace that is provided by PVC, right? And it will come via .volume.run namespace. Okay, this will be something there. If you see these all things, right? .volume, it comes under .volume. Okay, so coming back to this task, I said before in the beginning that these tasks are executed in order. Okay, when I say order, whatever order is mentioned in this particular policy, right, in this particular template and in these specifications, in this YAML, that is the order which will be run. So it will first run the volume service, right? It will first run this template called volume service. Then it will run the template named as volume path 0.6.00 and all those things, and then controller and then replica, right? So coming back to the task result, we know that the controller relies on the service IP. Even the replica relies on the service IP, right? We also know that the replica relies on the path. So this path is nothing but the storage pool. We have the storage pool claim and the storage pool, right? SPC and SP. So this is all about the volume path. I'll talk a little bit about that also. So like I was mentioning, volume replica also requires the path where the persistence will happen, right? And definitely for that path, it has to rely on the storage pool. The storage pool is something that will be created dynamically by the node bot and other components of OpenEBS. However, once that is getting created, the operator has to place the policy, and the operator has to mention what is the pool on which the volume should be deployed, or the persistence would happen, right? So he gives a value called, let's say, for example, SSD. Now, what is that? We'll look into the volume path, right? Okay, right. So here is the volume path. Okay, what it does, right? Let's look into the meta part. Okay, the run namespace, it is all same. It says that it has to run in a particular namespace, right? Well, we also have some amount of confusion. What is the namespace to be used for the storage pool, right? It may not really bother about the namespace, right? If in that case, we can actually completely hide it off. We can completely eliminate this off. Okay, I have not tried that, but this will be the case, right? And if it errors out, maybe there is a validation which is prohibiting that. We can remove the validation for this particular pool and all those things. But this is one thing, we can completely eliminate this out, right? And if you see the kind refers to storage pool. Now, this is not a kind which is supported by Kubernetes, right? By default Kubernetes installations. This is something that we support. That means we have extended Kubernetes as a custom resource, and we support that as whose kind is called storage pool. It has got its own API version and whatnot. And again, here, if you see, the action is get. So among all the templates that we looked at here, all these templates, the path is one which has an action called get. The other paths, right, the other templates have an action of put, right? So which is obvious because the storage pool is something that will be created by a different component, and it would be done prior to provisioning a volume. That is what the thought process is, right? So this template can be designed in that way, right? And one can design the template without trying to do some code behind. So the code behind actually has already been done. It is generic and it can understand via the templates. For example, what I am trying to say is, let's say in the future we want to provision a storage pool prior to provisioning a volume. We can do that, and we all want it dynamically. We can do that by just putting an action called put and giving a proper specification of the the storage pool. We can do that. However, it will be pushed. What this fellow will do, what this engine will do, is it will push that as a storage pool YAML, and the node bot running somewhere else as a controller, it will pick it up and it will do the job and it will get back, something like that. That is like, if at all the case demands, we can do those things. However, for the time being, it is a get operation. What it will do is it will get a storage pool with the name this, right? This is significance here. So it's again is from the policy storage pool value, right? That is what I was talking about. The value is nothing but the SSD. So it expects, so the path, if you look at this particular YAML, it means this expects a storage pool of name SSD, right? After the transformation, it becomes SSD. The object name becomes SSD, and it has to get it, right? And so after we get it, we have to get the path, right? If one remembers how a storage pool looks like, it has a path associated with it, right? So we have to get the path, and that path has to be set in the replica. Okay, I'll just task result. All right. So so if you see, okay, this is the path, the storage pool path. I'll come how come this particular stuff gets created, because this is not something which is mentioned in the volume policy, right? Even ID1 is something which has not been mentioned in the storage policy, right? So how does it happen? Okay. So now let's talk about the ID1 property, or even there is something called ID0, right? So ID0, ID1, and can be like, say, ID and some suffix, some numeric suffix. It translates to the index, right? To the order of running these tasks. So the service forms the zeroth task, 0, then the path forms the 1. It has the index of 1, then the controller has an index of 2, and the replica has an index of 3. So if we were supposed to get some value out of the controller, right, it has to be something called task result dot id 012. So id2 dot the specific property. Okay. So coming back to the service, we'll go to the pool path. The service index was 0, so it is ID 0, right? So then comes the service IP. How come this name comes up, right? So service IP, and then we have something called storage pool path. Okay, so currently the current code has been checked in, right? The service IP as well as the storage pool path, right? This particular thing, this particular property, as well as storage pool path. These are something that has been hard coded into the policy engine, right? So we cannot give any other property name here. It will not work. But eventually, it will be like, it can be generic. It can be very easily generic. The only thing that the engine has to do is it has to use JSON path, right? That is a library which actually can peek into the specific property and it can extract that, and it can be set here. So that is a little bit like ahead, sometimes later in the future we'll do that. But currently we know that we require a service IP and we require a pool path. So we have done it accordingly. Okay. Okay. So I have actually overshoot my time. And I have not yet gone through the major engine code. So how do you want me to proceed? Should we have in some other session, or should I continue now? Just let me know.
Let's check if I'm okay to continue, but let's see if others are okay as well. We can definitely do it in the next week if people have to leave. There's actually one more agenda item for today, which is to present the upcoming design for how these policy engines will be used for provisioning different types of storage. So today we are focusing on Jiva, which is a file-based, PV that requires a file-based thing. But we can also use a block-based thing. I would need 10 minutes to kind of present that.
Okay.
Anyone else? What's your time looking like, or any feedback? Should we do it in the next week?
I'm okay to continue.
Me too. Me too.
Okay. We can continue then, Amit.
Okay. So
let me just check with Nita also. He's recording this session. Is there any limit on the time that we can record, Nishanta?
No, we don't have any time limit for this. We can record as much as we like.
Okay.
Okay. All right. So this is something like okay. So coming back to the code, right? Okay. Let me try to. I'm just trying to gather my thoughts how to make it how to make it understandable in a very simple way, because from now onwards it's like pure coding. So we were okay. We'll go to the volume part. We talked about the volume, right? So what it was like it accepted the things from the handler, from the HTTP handler. It did something it created a hierarchical structure of the volume properties. That was run namespace capacity and the name, right? And then it also looked out to get the storage class. From the storage class, it extracted the volume policy, right? And then it invoked the policy engine. Okay, so this is nothing but the policy engine, right? Before getting into the code, again, the policy engine, what it will do, it's like it will parse the volume policy. The volume policy consists of primarily two parts, right? One is this policy part, then the other one is a run part. In the run part, that it has to run a series of tasks, which are nothing again but the templates, the name of the templates. And the templates are again a set of config maps, right? To Kubernetes user, it seems okay, but to the others, why config map and all, we can actually discuss it later, maybe on some channels or something. However, this is what a policy is. Basically, two parts. One is a policies part, and the other one is a series of templates that needs to be run. Before running the templates, what the engine does is it actually prepares this particular data in a hierarchical format and sets them to the template, right? And executes the template. Okay. After execution of the template, it invokes the Kubernetes APIs and gets them, puts them, or whatever. Maybe in the future it can watch or list or whatever. So now coming to the code, this is the engine part. Okay, so we are not from volume policy. Okay, so we see a structure here, policy engine. The structure is composed of the volume policy. This is again defined in the PKG APIs part. Okay, so I remember now the PKG APIs part. That is something that I must discuss here. I'll come back to the PKG APIs part, which is about again the code generation and all those things. Like one of the comment I have received in the PR is there are some 46 files that has been checked in, 46 changes in the files. However, I would like to say that the business logic lies in only 5 to 6 files, or maybe 7 files. The rest of the files are generated files, right? I would like to showcase that as well. Okay, so this is a engine which composes of certain number of things. The values is nothing but the same thing that I talked about earlier. It is a complex structure. It's a nested hierarchical. The values which will be eventually be set against the templates, right? One more thing. So this time when I actually started to code, I did not do from a top-down approach. When I say top-down, I did not do from the endpoint till the last part. Rather, I took up from the last part, like the policy engine, the templates and all. Those were the foundational parts that I took up first. I wanted to do it by composing it into proper structures, the proper objects. And based on my experience, I have seen that it will not lead to procedural logic. Otherwise, it actually puts you in a procedural frame, procedural logic, which is like always it will be changing, and maybe injection of bugs and all. So this is one of the things that I followed. I was focusing more on the structures part, and then came the behavior. Okay. If you see the policy engine, this is this instantiates the engine. It does some basic validations, right? And in order to run tasks, there is something called task runner. There is something called task fetcher. The task fetcher is the one which will fetch the tasks, right? Because all we have in the volume policy is the name of the tasks, right? And the namespace where the task reside. So the task fetcher is the one which will fetch the tasks from that particular namespace, right? And then there is a task runner. The task runner is the one which will run the task in a serial fashion. We'll come back to that. Okay, so this is, if we see further, like add policy values to policy TLP and all those things, this is all about like preparation of that hierarchical structure, right? So I'll not go into the details. I mean, one can see into that whenever they have time, and they can actually come back with review comments or in the channel. We will be discussing that. This is again the task results and all. Okay, so one more thing to do, this is what we are talking about, right? Task result, and that is some identity ID 0, ID 1 and all. So if you see the policy engine uses the concepts of task fetcher, task runner. Okay, and then also it prepares the values, right? The third thing that it does is it also has some closers. What is a closer? A closer is nothing but a function implementation which is passed as argument and then executed later. It is known as lazy execution, right? So the engine also makes use of closer specifically to extract the results, okay, the desired results, and then once it extracts the results, the engine has to frame it into this hierarchy, right? So this is the job of the closer. And as I say, the closer, this particular function add task results to task result TLP is a closer. And this becomes, the namings are like huge. I just not get to any simpler names. That is a different thing. We'll talk about it later. Okay, so this is preparation of task for the execution. This is again the same. It will fetch the task and it parses the YAMLs and provides the YAMLs with the values, and then this is all about preparation of the tasks, right? Okay, so that is something called get annotations. So annotations is the one which I believe, based on our experience, the annotations is the one which is actually the desired output, is actually the something that is desired, that is that other components would like to know what has happened, or what are the properties that have been set. And we saw that annotations provides us a good way to do that in a very generic manner via some key value pairs. So this is why the annotations is there. We'll see how that goes eventually, how exactly we will extract. And for extraction, I said that the policy engine will be making use of JSON path to make it generic if it is required. Otherwise, it will just settle down with the service IP, some of the hardcode stuff like storage pool paths, service IP, and all those things. Both the ways are there. We'll see where it goes. Okay, and this is the final execution. It prepares the task. It adds the values, prepares the task, and runs it. That is it. All right. We'll immediately go to something. So we are done here with the volume, right? With the volume package. Okay. After the volume, we go to the task. So in this particular PR, right, it is a volume package which has been designed. It is a task package which has been designed. It is a template package which has been designed, right? We already looked into the template. The examples that we are seeing is the template. There was another file which I have not gone into deep, because that is nothing but preparation of the YAMLs. It's a bit of a wrapper over the standard YAML. It's not much of significance. I mean, one can have a look at it later. Okay, so that was about template. We will get into task, which is more important. Okay, again, we go to the task, and what do you find? We find something called as fetch runner, and again, that is something called task itself. Okay, we'll go into the task directly. And one must be noticing I don't have any unit tests. I am doing them, and if at all I get some outside contributors, that will also be helpful. But again, based on my experience, I see that I mean, if I start doing the unit test from the very beginning, there'll be so many churns that at the end of the churn, I have to churn the entire unit test out and have some new unit tests. So I'm just trying to give some time for the unit tests. The time will be to see how the code evolves a little bit. So I'll be sending the unit tests in my subsequent PRs. Okay, so this is about the task. Okay, all right. So the task is a kind of a what can it have? It has all the elements of a meta task, and it has the elements of a task. And this, you can see the meta task, right? It is just the Go structure representation of the things that we saw in the YAML format, right? It's very simple. I mean, the ones who have been coding it, they will be seeing it as a familiar territory for them, right? These are the JSON tags, right? Or what you can say, some labels, or which if provided to the YAML library, some of the standard libraries, it will be able to unmarshal these particular properties into this particular Go properties. It's all about marshalling and marshalling stuff, and we need For that, we need a structure apart from the YAML, a Go structure apart from the YAML. That was what the meta. Meta has some of the informations like from the kind we can know if it is a deployment. These are all like very, very simple but very, very useful stuff that we have. Is it a storage pool? Is it a config map? Is it a put operation, delete operation, get and whatnot? All right. So one important thing about the task that we have implemented here is it is capable of rollbacking itself. Because it is a series, it's a kind of a workflow which executes a task in order in case of any issues encountered by a task in the midway, right? Task provides the ability to roll back. It will roll back the entire thing. After putting some logs and all those things, it will roll back the entire thing. Okay, and it will error out. Okay, so there are some logic written around rollback. Okay, so it preserves some of these identities, the object identities, in order to roll back, right? To give you a very simple example, if a service has been put, right, it will be put with a specified name, right? That will be stored. Okay, till the task is till the entire all the tasks are executed. In case of any failure, this store will be taken out. The rollback store will be used to take out the object that is a service that was created, and it will be deleted, right? All those things. Again, this is something we also wanted. The Maya itself, right? The API service itself to be, agnostic to the Kubernetes kinds versions or the Kubernetes versions. What is meant by that? Let's say deployment. We started with extensions v1 deployment, and now we see that it is apps deployment, right? So the versions have been churning, they have been changing a lot, and we really cannot depend on the compilation. We cannot really compile new Maya releases to support these versions. We have to have some generic stuff because we are really not dependent on the versions, right? So this is one of the things which actually enables the versions. It checks for different versions and it actually goes ahead and uses that particular version. This is required because of the client Go way, the way we try to use a client Go library. It has got a lot of abstractions around each version. A deployment may be having a couple of versions, right? Alpha, beta, and the V1. So client Go library does a lot of wrapper, provides wrappers for each and every version. And that is how the consumers, right? The calling libraries have to code to these versions. It actually becomes a lot of complex, which I believe it can be managed in a better way. But we will do that sometimes later, not now. So till that happens, we have to do all this stuff, like we have to check it is which deployment, which version of deployment and all. So it's not exactly we are managing or we are agnostic to Kubernetes versions, but we have to do a little bit of changes to support a particular kind of a Kubernetes object. However, that can be managed. There are ways by which it can be managed without compiling or recompiling the code. Okay, coming to the task. The task is again it composes the meta task. It will again definitely have the values and it will have a YAML, and this is the one which will do the Kubernetes invocations, the API calls, right? If you see the code, it's all about like it will execute as a put of deployment, or let's say get of the storage pool, or delete of a service, or delete of a deployment, and all those things. As we keep on adding new stuff, let's say we want to add a stateful set, we have to add its put, get, delete, and all those things, right? And this definitely means we are changing the code. I agree there is a recompilation and we change the code, but eventually this will not be all of this will not be required. We'll talk about it again a little bit later. We're running short of time. Okay, there's something called rollback, like I discussed earlier, and there are some some structures and some methods dedicated to rollback only. It will do the rollback in a proper way. Okay, like this is all about like if you see something starting with as extension one deployment and all those things as service. This is when this is nothing but unmarshalling a template into the corresponding Golang Go object. In this particular thing, as extension v1 b1 deployment, it unmarshals a template to a extension v1 b1 deployment object, right? So this is the one. This again, this particular object has been provided by client Go library. So that's the reason why this method is there. It unmarshals that. Similarly, the service, it has to unmarshal the YAML purpose service before pushing that service into action, right? So, and obviously this will be invoked, these operations from the put and delete and get operations, right? So this is all about logic. It's nothing complex out here or nothing really great. This is all about the standard logic that that is in place. So the task, finally, if you see the task.go, it describes a meta task in a Go structure. It describes a task in a Go structure. It has some ability to do the rollback. It unmarshals the YAML templates into Kubernetes specific Kubernetes objects. All right, and it invokes Kubernetes clients for the specific API invocations. Let's say get, call, get, delete, put, and all the stuff. We'll stop about task here. Gedit. We go to, okay, before runner, we will go to the fetch. Let's see what the fetch does. All right. The fetch should be simple, and it is simple. It has like it's a kind of an interface. I have to talk about here why this is. I guess out of the entire PR, this is the only interface that I have coded. All right. I do not want to code. I do not want to make it. I mean, more and more interfaces and all, because I thought that was unnecessarily complicating the entire logic. We will use interfaces only when it is required. This is again a deviation from the design that we did in till 5.0. Okay, we will go for interfaces definitely, but only when it is required. Only when it makes some sense. Here, why the interface? Because I feel currently what we are doing is we are fetching the task from Kubernetes. That is, we are fetching it from the etcd stuff, right? Maybe in the future we might have to fetch it from, let's say, GitHub repositories and whatnot. So that's the only reason it has got an interface. But there is no logic related to GitHub fetch and anything else other than Kubernetes fetch. All right. Okay. We'll come back. So we'll get back to the fetch. So what it does is it invokes the Kubernetes APIs and gets a config map, right? And after getting the config map, it gets a meta and gets a task. Like if you have noticed, in our config map, when I say our config map, it's like the templates, the OpenEBS templates that exposes. There are only two important things. One is called meta and one is called task. These are the only two things. Inside that, everything happens. So the code is only interested to get the meta and get the task. That is it, nothing else. So this is all about fetch. Okay, finally we get back, we'll go to the runner. This is, kind of, important. In this package, in the task package, this is the file which will be invoked by its clients. So the policy engine will definitely be interested to invoke the runner, right? The functions and the methods of a runner. And obviously it also has to depend on fetch, because without fetching we cannot invoke the runner. So all right, so coming back to the runner, there are some set of structures which are required to hold the task, the meta task YAML as well as the task YAML. And again, there are some methods for rollbacking. This is all planned for rollback. This is not rollback, but it's a planning for rollback, right? So in case there is an issue, this will be useful. Okay. It appends all the rollback information that it has, and in case of an issue, okay. So then this is the actual rollback. That means an issue has happened, and this will be called, right? And it will keep on executing in a reverse order. Okay. All right. So this is the run tasks. So the main method here is a run. This is the public method which will be exposed to the clients. It calls the run tasks. If there is any error, it will roll back. Within the run task, there are some plannings for rollback, and there are some preparations and so many things, stuff, right? It will do all the stuff. What it does, the main thing is this execution. Execution is that the task execution, which is nothing but the first file inside the task package that we saw, this execute command. It will call this particular method, right? So the runner will do that. It will try to parse the results, and in all these things we can do some, like I said earlier, we can do some better things here. We can make use of some libraries, some JSON libraries and all, to get the specific results. In other words, what you want can be specified in the meta, and you will get that, right? So this was all about the running of the task, right? So we are through the business logic part, right? Okay, so the task is one, template is the other one, volume is the third one. These are the three things which has the business logic of this entire policy. Okay, now we'll look at the other things like APIs. Why? Because this is where the volume policy is defined as a custom resource, and because of the need of a custom resource, we have used generators. We have to generate the code, and that is why the PR has become like a little bit bulky with so many files. We'll go to the APIs. Okay. All right. So it's very important to know these naming structure, right? The packaging structure. It is advisable to use this kind of domain. Let's OpenEBS.io, which we are, and because it's a V1 Alpha 1, we have only the V1 Alpha 1 as a version. So this is what we have, and we'll go inside that. What we'll have it. Okay, we have something called policy register types, and there is something called generated.go, right? Till now, we have been using these types. Register is something, again, this is a default stuff that we do. I will have a little bit look about a register, and this is something called policy. We'll also have a look. However, among this entire package, this is a thing that we don't need to bother about. This is something that is generated. All right. Okay. Now we'll go back. We'll go to the types. Gedit types. You will see there is some information called storage claim. There is something about storage pool, right? And there is something on volume policy. So we have defined the specifications, right? As per our custom resource, we have defined it here, right? Whatever you see as YAML in the volume policy, you will see those corresponding Go structures mentioned here, right? And we have to be very, very, very careful about mentioning the exact JSON property, because a policy's YAML will be translated into the policies here in this 85 line number, whatever you see. A run in the YAML will be specified, will be converted into run tasks, right? So if you see the run task, that was run task. If you see the run task, it will be having something called search namespace, which will be converted to search namespace here, and tasks here will be converted to an array of tasks, right? Coming to the task, we'll see that the template in the YAML gets converted to template name, the identity. Okay, so these things has actually, I have not exposed them in the thing. I thought it might be required to even have the API version and the kinds and all exposed as a policy inside the task and all. But then I have not exposed it. We will see how to actually utilize it in a better way. In other words, what I mean to say is we may not require this, but it's still there. We'll see. We will have to see how to better utilize the API versions and kinds in the policy. Okay, so this is all about that. Let me so about this thing. This is one thing that I was like bothering about. I was bothered like how to make it a cluster level, because if we do not have this, the client code that will get generated will want us to give namespace. But currently, as per the current thoughts, we don't want to be namespace. We want it to be a cluster level, which again may change. But having said that, with the current scope, we have to do this annotation, right? We have to write it as non-namespaced. So it will not associate the entire things with namespace. And we have to do it at multiple places, right? So these are some of the things that we have to do. The other things like deep copy, who is the one, these are all things, this is a very specific part of API machinery group, right? In the Kubernetes API machinery. If one actually keeps a track of that, this should become a little bit easier. Then again, there is some status. Let's not go into the details, but this is all about that. Okay, so we'll go to the register part. This is again, I think I've just added it here. As I understand it, it is not required. If we are using if we are actually registering our types with those annotations and invoking the script that generates the code, okay, this is not required. If we are not doing those auto generation stuff, then this kind of registrations will be required. Okay. However, I did not have time to get into all these things, so I just added it here as well. I did it when during the SPC and SP time, that is storage pool claim and storage pool time during those times, and I have done it this time as well. I just don't want to bother about this. I've just added it here. But more specific, but whatever I understand, this may not be required.
Amit, it's required for generation of your code. Actually, if you're not registered, if you do not add your types here, it will not generate your code.
Okay, maybe that is a thing, but I have not seen. Why I'm saying that is because there are some comments which something on like manually written functions. We only register manually written functions. Anyways, let's not bother about that. That's okay. Yeah. It's good. Okay. So GR8, then there is something called policy. Okay. So this is something. Okay. This is again a deviation from our earlier ways of writing. We were writing into types, right? If you remember, we were under the Maya folder. We have types v1 and so many things, where we described the API specifications there, right? With this, we are actually using policy. We are using it inside the APIs, the way Kubernetes uses. We are also bound to use that because of our, CR things, the custom resources. So I have also put the policy here. So what is policy here? Okay. This is nothing but those top level stuff. I have given enough explanations here. One can go ahead and understand and come back to me if at all it is not understood. There are some comments, obviously, we will remove them. Okay, commented code like here. Okay, so what I see is the things that we will be also probably be having something called volume.go here, which will define the volume specifications. Okay, v1 alpha 1 volume specifications, which is currently there in the v1 of types / all those things, right? We will be doing those things as well here. This is again the code that we have done. Policy types, I had registered those types, and here in the types.go we have described the structures. After doing this, what one has to do is this is very generic to anyone who's trying to develop a custom resource. After doing this, one has to go to the root of the folder, right? And go to build scripts. What do you see here? We see something called scripts, and there is something called update code gen, right? We have to invoke this particular shell script so that the code are getting generated, right? So what are those generated code? PKG. If we go back to the PKG, they are getting generated in the client, okay? And I think it's only the client. Yeah. Well, let's go into the client package. What do we see here? We see something called client set. We see something called informers. We see something called listers. Okay, these are the three things that gets generated due to the code generation utility provided by Kubernetes. The other clients are something called Jiva, Kubernetes, and MAPI server. These are our own custom built ones, right? Jiva is to make client calls to Jiva, and Kubernetes is to make client calls to Kubernetes, the API calls. Again, this is where like majority of code gets generated, and it kind of pollutes the entire PR by making it really heavy with the number of code. All right. So this brings an end to our code walkthrough, right? So do we need to do a demo? Anyone is willing? Or
Amit, thanks for the session so far. Actually, I learned quite a bit about the texting and the text templates, and also a little bit about CRDs. It's pretty useful. One of the intent is, there's a huge PR to review it, to get some background. I think this session helped me in that direction.
Yeah,
I will be now confident in reviewing the PR that you post. I think in the interest of the time, maybe the demo itself can be pushed to the next week.
Okay.
And once we have a proper image, we can actually do a live demo.
Right.
Let's see if anyone has any other questions, and then. All right. In the interest of time, let's probably wind up for today. And I'm also going to push my talk into the next week's agenda. And people can add their own agendas or items that they want to discuss for the next week. If there are no questions, then I think we can probably end the call for now. Thanks, everyone.
Thanks, Amit.
Thanks all of you. Thanks.
Thanks, Amit.
Thanks so much.